All right, so once we've finished with prime factorization, now we can use that to help us simplify square roots. So if I've got 360 and I'm taking the square root, so square root of 360, I need to enter this into as my answer in the form of 6 times square root of 10. So how did I get from those? Now, either of these will have the same decimal. They're approximately 18.97, etc. But here's what we're going to do. Since it's square roots, if we look at pairs of 2, right, so here's a pair, here's a pair. Groups of 2 are what can come out, because 2 times 2 is 4, and the square root of 4 is 2. So I could rewrite this as root 4 times root 3 times root, and then the numbers left inside are a 2 times 5, which is 10. So I like to put a box around the values that stay inside the root, and then circle the pairs that are coming out. So 2 times 3, actually let's do this, just so you can see where the inside came from. So root 4 becomes 2, root 3 becomes 3, the square root, and then inside that root was 2 times, not 10, 2 times 5. And that's where my root 10 comes from. So if I multiply that outside pieces together, there's my 6, root 10 is what's left inside. So when you're square rooting a value, you always have 2 options. One, it's a perfect square, and that's something like 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 4, 9, 16. The other option is its irrational number. Which means if you plug it into a calculator, it gives you a decimal, and it's irrational because that decimal goes on forever. We don't want to round it. We want an exact answer, so while we cannot write something like 4 or 6 if it's an irrational number, I can simplify it to that form.